How are you all? I hope you all are doing well. I am your 9th class physics teacher. As you all know, I am Raj sir. So, in our last class we are discussing about reflection or refraction. Sorry. So students, there are a lot of concepts are there, lab activities are there. Those activities you can understand from our digital classes, okay, which we are sending to you. So please observe keenly. Still you cannot understand, then please inform the school. Okay, we will let you know soon. And today we will start the laws of refraction. Okay, I'll tell you what exactly are laws of refraction. Okay, and let's get started. So let me write heading for laws of refraction. Today we are learning what exactly are laws of refraction. Okay, student, for this we need to draw a particular diagram. What exactly is the diagram? The ray diagram. Suppose this is normal, this is a surface. This is normal, this is a surface. Let us assume this is rarer medium. This is suppose denser medium. That is rarer medium, this is denser medium. Okay, a ray of light is coming. It will incident on the point O, right? It is incidence. The incidence point is called point O. Then it should what? It will be refracted. It will come towards the normal. It will come towards the normal because it is coming from rarer medium to denser medium. We have learned in our previous classes. This will be called as incidence ray. This will be called as refracted ray. This will be known as refracted ray. This is your incidence angle. This is your incidence angle I. This is your refracted angle R. So this is smaller. Okay. Is it clear? Okay. This is our normal. This is our normal. So here, students, first law of incidence. What first law of incidence is saying that the angle of incidence, the angle of refraction, the surface, the point of incidence, normal, all will lie on the same plane. They all will lie on the very same plane which you have taken. This is our first law. What second law is saying? Second law is saying that our second law is known as our Snell's law. Okay? Second law is also known as Snell's law. Soon you will get to know about this. What exactly is Snell's law? Snell's law I will tell you little bit later. But let me tell you what exactly is your second law of refraction. During refraction, the light follows Snell's law, that is sine of angle I by sine of angle R is equal to constant. Okay? What is saying that sine of angle I with respect to sine of angle R is always constant, and that constant is always known as refractive index. That constant is always known as refractive index. Is it clear? Okay. So let us write the laws. And here is this one. This is what our diagram was. So let me write here the first law. What first law is suggesting? The first law is saying that let me make it easy for you. See what are the things I am writing: the incident ray, the refracted ray, okay, and the normal to the interface, the normal through interface of two transparent media. Now, this is your normal, or you can say your this is normal. This is what our interface. Okay, the normal through the interface of two media, all rely on the same plane. They all rely on the same plane. As you can see, I can draw everybody on the blackboard, right? On this very green board, I have drawn each and every angle. Nothing is coming out, nothing is three-dimensional. They all are lying on the same plane. So this is what our first law. Second law tells that, what second law is telling? During refraction, light follows Snell's law. What is Snell's law? Snell's law is suggesting that sin I by sin R is equal to n, or you can say constant. What? Constant. You are getting what is Snell's law? Snell's law is here I write, okay? I write here. N1 sin I is equal to N2 sin R. N2 sin R. See, refractive index multiplied by the incidence angle is equal to refractive angle, refractive index, and multiplied by the sine of the angle of refraction. They both are equal. That's what your Snell's law is saying. When n1 by n2 means refractive index of first medium with respect to second medium is known as refractive index itself, right? Relative refractive index. And sin I by sin R is equal to n. Here, just I have what? N1 by n2 is equal to n. That's what I have taken. So this entire thing comes to what? Snell's law. So these two laws are very important. Okay, I hope you all were mentioning these laws, right? Student, next concept is your total internal reflection. Okay, what is this total internal reflection? What is total internal reflection, students? See, here one thing is given. When the angle of incidence is greater than critical angle, the light ray gets reflected into the denser medium at the interface. That is, light never enters to the rarer medium. This phenomena is called total internal reflection. Let me simplify it for you. Then I will write this particular explanation. Okay, and I think this will be probably our last concept of this particular chapter. And rest all things, the activities, the lab activities, everything you will be getting in our digital class. Okay, in a much easier way. So please follow digital class along with this lecture. Okay. So here what they are saying, you will see total internal reflection. Now laws of reflection completed. So let us raise this one. See students, let me write here. Now we are reading refraction. from where this reflection comes from. That's what. This is a kind of refraction, but which is giving us reflection. In our first class, means when we were reading about our refraction or reflection, I told you that opaque objects will always give us reflection, and your transparent objects will always give us refraction. An opaque object cannot give you refraction, right? But here, a transparent medium itself is giving reflection, which is impossible. A glass can never reflect your image, but here it will reflect. How? Let us understand. How? Let's understand. Suppose this one is your rare medium. This is your denser medium. Fine. Suppose the ray of light is incident from this side, means denser medium to rare medium. Suppose the ray of light is going on. How it is going on? Suppose like this is going on. See students, what happened? The ray of light, suppose it is going from denser medium to rarer medium. When it is going from denser medium to rarer medium, what will happen? Okay, that should go away from the normal now. See, here the angle is close, but there the angle is little bit what? More. Why? Because whenever the ray of light is going from denser medium to rarer medium, it will go away from the normal. It will go away from the normal. So let us do another thing. Now what we will do? We will make this angle a little bit more. Now it will deflect like this. Isn't it? Now it will deflect like this because what? You know that whenever you are doing like this, it is entering to rarer medium, the reflection means your refraction will be more. First one thing, please remember your previous classes. There I have already explained you when the ray of light is going from rarer medium to denser medium, the light will come towards the normal. But if it is going from denser medium to rarer medium, the light will go away from the normal. It is going away from the normal. And you are increasing this angle more and more. At some point what will happen? At some point what will happen? It will go straight with interface. It will go straight with interface. This particular thing is called critical angle. This particular angle is called critical angle. If here when the angle of incidence is greater than the critical angle, if the angle of the incidence is improving, means it is suppose improvising the critical angle. If it is preceding the critical angle, what will happen? Critical angle से ज़्यादा हो गया तो, then what will happen? This light won't go into that medium. It will stay in this medium only. It will come into this medium only. It won't go that side. Okay, it won't go the outer medium. मतलब rarer medium में जाएगा ही नहीं. This is what total internal reflection. You can see a diamond, right? Suppose diamond is very old, means very old also, and it is kept inside a box for minimum 50 years. If you will see, you cannot see in obviously you cannot see diamond in what you call dark room. But give it little light, give it little amount of light, and keep the diamond upon it. You will see the entire room will be dazzling. Yes, the entire room will sparkle if diamond is a little bit bigger. Even if you stop giving lighting also, it will start to sparkle. Why? Once light enters into the diamond, it cannot come back. It cannot come back. It will be reflecting in its surface only. If light will enter into it, it will be like striking different mediums. Inside it only it will be trapped. The light rays will be trapped inside it. It won't come out. This is the phenomenon of diamond, which is dazzling. So this particular phenomena is total internal reflection. There are various cases, and you need to find out what are the cases for total internal reflection. And again, let me give you another example. You all might have heard a word called broadband. In our house, people are using that broadband connection. The rays of broadband connection which is coming to our home is also because of total internal reflection only. Because of this only, the broadband connection is also coming to our house. Okay, the wire is coming. Here the light rays are doing total internal reflection. Okay. You know, students, formation of mirage. What do you mean formation of mirage? See, in summer season, suppose you are walking on a concrete road. You are walking on a concrete road. Now you will see the road, the far of the road will look like little bit water. Watery surface you can look. That watery surface is called as mirage. Means the water vapors are creating over there. So you will think that there, what is there? Water is there, but nothing is there. In desert also, at some time when lot of distance people will walk now, then they will think that their water is there because it will look like water in desert. But if you go there, nothing is there. This is called mirage, and this mirage phenomenon is also because of total internal reflection. Okay. The brilliance of diamond, optical fibers, these all are example of your total internal reflection. Okay. See here it is given. Total internal reflection is the basic principle behind working of optical fiber. An optical fiber is very thin fiber made up of glass or plastic having radius about 10 to the power minus 6 meter. A bunch of such thin fibers form a light wave. See dear, what is happening? When optical fiber cable is coming to your house, it is made up of glass or plastic. It depends, okay, it depends what we are taking. And what here it is given? It is made up of number of such pipes. These pipes radius is 10 to the power minus 6 meter. बहुत छोटा है. Okay, it is very small. How much it is? Only 10 to the power minus 6 meter. So isn't it small? Yes, it is very small. Okay. Now bunch of such fibers, wires will come together and they will make what? They will make your light pipe. Which pipe? Light pipe. Now it shows the principle of light transmission by optical fiber. Sketch. Here you can see the image also. Okay, the image of your what you call this optical fiber. You can see in your book. Okay, it is available, easily available. You can see in your book. Okay. Here, because of all the small radius of the fiber, light going into makes a nearly glancing incidence of wall. The angle of incidence is greater than that of critical angle, and hence total internal reflection takes place. The light is thus transmitted along the fiber. देखो बच्चों, what is happening? Suppose this is optical fiber cable. Okay, optical fiber cable. In this optical fiber cable, what will happen? The light will be incident. The light will be incident. When the light ray is incident upon it, what will happen? The light ray will not gonna cross the border. Although it is made up of plastic and what you call glass, it won't go out because it is exceeding critical angle. After critical angle clearing, where it will come? It will come here only. Again, here also the same phenomena will happen, and like this it will go on forward. The rays will go on like this. So once they will remove, means spread the rays, and those rays will perform total internal reflection, and they will be transmitting forward. You just think those broadband waves, they are sending from much distance, right? But it is coming to your house within the blink of eye. How it is coming? It is coming because of it is coming through light speed. It is coming through light speed. And you might have seen, suppose you need to switch off your broadband box. You just switch off your broadband box, again switch it on. You will say it won't come. It will take little time so that the internet will come to you, right? Yes, it takes some time. Why? Again those rays of light should come to you. When those rays of lights are coming to you, then only you will be able to get that. Is that clear? Now this is the end of our chapter. See, all organs of the human body are not accessible to naked eyes of the doctor. Even you see where total internal reflection works. All internal organs cannot see, like doctors cannot see all internal organs as we cannot see. So what they do, the doctor insert an optical fiber pipe into the stone. they do insert or optical fiber cable into the stomach through the mouth. Light is sent out through the one set of fiber in the pipe. This illuminates the inside of the stomach, and light from the inside travels back through the another set of fiber cable and views that image of the outer end. The other important application of fiber optics is to transmit communication signals through light pipes. For example, about 2000 telephone signals approximately mixed with light waves may be simultaneously transmitted through the optical fiber. The clarity of the signal transmitted this way is much better than other conventional methods. See, my dears, what is exactly happening? It's done. Okay. Now, suppose in our stomach, some problem is there. A doctor cannot see what exactly is there inside our stomach. So what it will do? It will send two pipes. One pipe it will send. The pipe will go illuminate the entire stomach, and it will send another pipe, and those light rays will come through this small pipe. Okay, come out. So they will, while coming out, they will bring pictures also. Reflection, right? Always reflection means what? You will get picture. If reflection is not happening, you won't be able to see the picture. So in this way, inside view will come out, right? And even here it is written that telephone communication panels. You see, optical fibers can transmit communication signals through light waves. Okay. For example, about 2000 telephone signals approximately mixed with light waves may be simultaneously transmitted through a typical optical fiber. देखो बहुत सारे ऑप्टिकल केबल ऐसे हैं, different kind of optical cables are there where number of telephone cables are coming. Okay, and from there only the internet connection is coming. Nowadays Geo fiber is coming. Nowadays Airtel fiber is coming. BSNL was there, Hathway is there, Act Fiber Net is there. They all are sending you these all light rays and all. Means the internet, faster internet connection to you with the help of this only. Now you might have asked, sir, what about our phone internet connection? It is coming wherever we are standing. Yes, this thing is coming wherever you are standing, but it is not as fast as your broadband. How it works? It works through satellite. It works through satellite. And sir, what about them? They do have used pipes. Yes, they do have used pipes. Your entire sea, Samandar, inside sea, there will be big pipes, more than our room. Big pipes will be there. And from there, lot of rays are sending. Airtel and Geo also. Those rays will what? Those rays are coming, and those rays are coming to our satellite tower, and from that tower it is going to our troposphere. Again, it is coming to each and every device where the device is capable of recognizing that symbols, recognizing that signals. And in this way, you people are using your internet connection also, and Geo and all. Everywhere these optical fiber cables are used, and it is a revolutionary thing. Before these things were not there. Okay, when these optical fiber cables came, everything changed totally. Okay. So this is the end of our chapter, my dears. And lab number, your activity number 8 is there, refraction through glass slab, and a lot of things are there. You people will be getting by our digital class. Probably you have already got these digital classes. Okay. Here the important concepts are refraction, what is incident ray, refracted ray, angle of incidence, angle of refraction, your absolute refractive index, what is relative refractive index, what is Snell's law, what is critical angle, total internal reflection, mirage, optical fiber. These are some kind of things which you need to understand. I hope you all will understand. Let me give you a little bit idea about refraction through glass slab, how it is happening. This experiment we all can conduct at our house also. Okay, so I won't tell you the reflection, the experiment how it is done. That you can get from your online class. You will get in your digital class. But here I will explain you how it works. You will take a glass slab. Okay. Now after taking this glass slab, what we will do? You will see, we will place two pins over here. What we will do? We will take two pins over there. Now what we need to do? We need to see through it. Okay, we will draw one straight line. We will remove these pins. Okay, we will draw one straight line. We will draw one straight line. Now you see, if light is going through glass slab, it will follow what? At first it will come closer to the normal, and after that it will go away from the normal. After that it will go away from the normal. First what we know the rule. Whenever light is coming from rarer medium to denser medium, it will always come towards the normal, and again it is going from denser medium to rarer medium, it will go away from the normal. In this way, you can get your images over here. The emergent rays you will be getting over there. So here what you need to understand, let us name it A, B, C and D. The same principle which I have said. If suppose this wouldn't have happened, matlab, if glass slab is not there, refraction is not there, how the light might have gone? It should have followed this particular path now. It should have followed this particular path now. This particular path is known as what? From here, the light came here. This particular shift is called lateral displacement, or you can say shift. You can call it as shift, or you can call it as lateral displacement. Fine. I hope you all have understood. So this is the end of our class. Okay. I didn't left anything. Application of concepts, very important. Please do it. And high order thinking skills you need to do. And multiple choice, reflection of concept, they are very easy. I think you can pick up each and every point from them. Single point you can pick up from them. Everything, each and every answer you will be getting from book. Suggested experiment and project works are there. This we will think about later. Suggested experiment are very important. This, you know, these particular things which are given over here, you will perform the very same experiments in your 12th class. When you will be going to your 12th class, this very same experiment you will be performing. So please do it, and do not forget to watch digital classes nicely from first to last. And this you all have understood. This is the theoretical thing which I have explained. In digital class you will be getting how it is done, like how we will perform this activity. That will be explained over there with nice PPT presentation. You will be getting over there. Watch this, watch that. Okay, and do your question and answers. Again, if you are finding any doubts, please consult with Radha ma'am. Okay, we will be here to help you. And until then, bye. Thank you so much.